So, hello students. In this session, we will talk about simultaneous equations and different methods of solving them. Okay. So, we will talk with the basic and the primitive methods, that is substitution, elimination, RCM. Then we'll move on to matrices, where we'll talk about Kramer's rule and also the Gauss-Jordan elimination method. Okay. So you can choose what is apt to you as per your standard. So let me just start off with the equations. I have 2x plus 5y is equal to 21. 2x plus 5y is equal to 21. Okay. And my next equation is x plus 2y is equal to 8. So, two equations. I've chosen them because of they are two simple equations, and to explain the different methods and for a comparative study, I felt these two equations are suitable. Okay. So remember one thing, regardless of the method doesn't matter. It's only that depending on the question, the syllabus, that you will have to go with that accordingly. I mean, go with that method. But otherwise, you can see that the answers will be the same, and you can understand which method is easier, which method is suitable, and which method is lengthy, which method is not lengthy, and so on. Yeah. Let's see. Let's start off with the 2x plus 5y is equal to 21 as the equation 1. X plus 2y is equal to 8, which is equation 2. Now, let's come to our very basic method, that is the substitution method. Okay. So, if I'm just asking you to solve, we can go with substitution. Now, what is so big in substitution? Nothing big, isn't it? You're going to solve for one. You're going to substitute for one in terms of the other. Substitution. Okay, substitution. Let me just write that down here. So in substitution method, what we do is we are going to substitute for x in terms of y or y in terms of x. Now I told you in substitution method, you have to look at the two equations and see which has which equation the coefficients are smaller in value. It's obviously 2, isn't it? So in equation 2, you find x plus 2y is 8. The coefficient of y is 2 and the coefficient of x is 1 by default, isn't it? We don't really write 1x, but it's implied as x. So when I take equation 2, I will substitute for x in terms of y. I have chosen equation 2. So x is equal to 8 minus, push this to the RHS, it becomes 8 minus 2y. And this value, I'm going to put it in equation number 1. Yeah. I substitute for the variable from one equation and put it in the other equation. So now I have 2x plus 5y is 21. That is my equation 1, isn't it? I have taken equation 2. I have substituted for x from equation 2, and I'm going to put that in equation 1. So what is x? 8 minus 2y, and that will come here. Okay. So 2 into x, instead of x, I will put 8 minus 2y plus 5y is equal to 21. And my next thing is just to expand this and solve for y. It has now reduced at this step. See, I put a tick mark. It has reduced to a linear equation in one variable, which is y. 16 minus 4y plus 5y is equal to 21. Okay. So minus 4 plus 5 is becomes 1. 16 plus y is 21, or y is 21 minus 16, which is 5. Isn't it? So we obtain y is 5. So I don't stop at this, because now I need to know x, isn't it? And I can use this value of y in either equation 1 or 2. Let me go with the equation which has smaller coefficients, so it becomes easy for me to calculate. So equation 2 says x plus 2y is equal to 8. So let me put y is 5 there. X plus 2 into 5, in the place of y, I'm going to put 5. So x plus 2 into 5 is equal to 8, isn't it? X plus 2 into 5 is equal to 8. That gives me x plus 10 is 8, right? Or what is x? 8 minus 10, which is minus 2. So I've got the values of x and y from this equation, from these two equations, by this method of substitution. So in substitution, what have I basically done? I have just substituted for x in terms of y and then solve for this variable equation, that is using this where we have equation 2 variables reduced to an equation 1 variable, and finally I have been able to derive the value of y. Substitute the value of y in. This is, of course, this is very much a substitution. So that is done. So the next method we shall see is elimination. So we have 2x plus 5y is equal to 21. Okay. And the second equation is what? It is x plus 2y is equal to 8. Okay. See, whatever I'm doing here, it's like a comparative study. Like you can understand, you can analyze, you can compare the two methods. All right. And now it's elimination. Now I can choose to eliminate y or x. See, the second equation, what is the coefficient of x? It is 1. So I can eliminate either x or either y, but since coefficient of x is 1, so what is it? And the coefficient of x is 1 in equation 2. In equation 1, the coefficient of x is 2, isn't it? So what is the LCM of 1 and 2? It is 2, right? So I already have the coefficient of x as 2 in equation 1. So all I need to do is my equation 2, I need to multiply by 2 so that I get 2 as the coefficient of x. So what happens to my new equation 2 now? It is 2 into x plus 2 to the 4 into y is equal to 16. That is my new equation 2. I can call it as equation 3. Okay. And then what is my original equation 1? I'll just keep it. I didn't change equation 1, isn't it? 2x plus 5y is equal to 21. That is my equation 1. I just brought it down. Now I can, what I can do, equation 1 seems to have bigger coefficients, isn't it? So I can do equation 1 minus equation 3. Let's see what happens. Yeah. So we'll do equation 1 minus equation 3. What is equation 1? 2x plus 5y is equal to 21. And equation 3 is 2x plus 4y is equal to 16. So you just have to do subtraction, isn't it? Not this one. It is 1. This is equation 1. This is equation 3. Subtraction. When you subtract, of course, the signs will change. Your minus becomes plus and plus becomes minus down here. So you get, what will you get? You will get 0, 2x minus 2x. 5 minus 4 is 1y, or simply y I can say. 21 minus 16 is 5. See, I got y as 5. I got the value of y as 5. So, and that now I'm free to use this value of y in equation 1 or 2. So if I'm going to put y is equal to 5, I've got, isn't it? I can put the value of y is equal to 5 in 1 or 2. Equation 2 has smaller coefficient. So I can put y is equal to 5 in 2. So 1x plus 2y, isn't it? 2 into 5 is 10. I'm talking about equation 2, remember, is equal to 8. Yeah, if you're able to see, I'm relating this to this now. And x is equal to 8 minus 10, which is negative 2. See, I've got my value of x and y. This is elimination method. Substitution we have seen, isn't it? This is elimination. Okay, so now you can compare. You can see which is better, which is faster, which is easier, which involves more strategy, which involves more computation, and so on. So you can analyze from different methods. So move on, children. Next is the RCM, the cross multiplication method, the rule of cross multiplication, which is another interesting method. Okay, so let me write the primitive two equations. 2x plus 5y is 21. Yes, 2x plus 5y is equal to 21. The next is x plus 2y is equal to 8. Isn't it? Now I'm not just going to use them like this because it's very important that in RCM you need to have 0 on the right hand side. So I'm going to rewrite my equation as 2x plus 5y is equal minus 21 is equal to 0. Yeah. And the next is x plus 2y minus 8 is equal to 0. Okay. So now what to do is, if it is it's in this form, right? I'm going to write the coefficients now. Coefficients of x, y, and the constant term. So from equation 1, what is it? If this is equation 1, okay, I'm going to write 2, 5, and the constant term. That's 2, 5, constant term. And one more time I will write 2, 5, and the constant term. Likewise, in the second equation, I mean, here the coefficient of x is 1, right? When I just say x, it's understood to be 1x. So this 1, 2, and -8. Yeah, the coefficient of x is 1, coefficient of y is 2, and -8. 1, 2, and -8. Now fence out the borders. We don't need them. And now what I'm going to do is, I'm going to write x between these two. Between these two, I'm going to write y. Between these two, x. Between these two, it's y. And between these two, it is 1. Isn't it? So I have kind of made compartments x, y, and 1. Now I have to write x divided by this product minus this product, like cross multiplication. 5 into -8, okay, minus 2 into -21, okay, is equal to y, isn't it? Divided by, now see, -21 into 1, that is this product, -21 into 1, minus -8 into 2, -8 into 2, -8 into 2. That is equal to, next is what? 1 upon this product, 2 into 2, yeah, minus 1 into 5. 1 into 5, of course, we'll just write that 1 into 5. Okay. So it will be 1 into 5. That implies x by -8 into 5 is -40. Minus into minus is plus. Plus 2 into 21 is 42. Is equal to y upon -21 minus into minus plus 8 2s are 16. Be very careful with signs. Okay. See, I'll just show it to you here. It's always this way. It's always this product minus this product. Yeah, downward arrow this way minus this. Okay, going back to this. So we have x by this is equal to y by this is equal to 1 upon 2 to the 4 minus 5. So you know what I have done, isn't it? So I have taken x upon 5 into 8 this way minus this way. You can see that I'm marking it in yellow here. The same thing is equal to y by this product minus this product is equal to 1 upon this product minus this with cross multiplication. So now this reduces us to what? So I might just write it here because there is space. X by 42 minus 40 is 2. Y by 16 minus 21 is minus 5 is equal to 1 by 4 minus 5 is minus 1. Now I got 3 equations, isn't it? So x by 2 is equal to y by minus 5 is equal to 1 by minus 1. And then you can take these two because x, and this is a constant value term, and here you can take these two. So we get x by 2 is equal to 1 upon minus 1. Cross multiplying, you get minus x is 2, or x is equal to minus 2. And if you take y by minus 5 is equal to 1 by minus 1, minus y is equal to minus 5, or y is equal to 5. So we got the values using cross multiplication, rule of cross multiplication. Now the next thing that is left is matrix method, and we can also see we can use Kramer's rule. So Kramer's rule is 2x plus 5y is 21. So 2x plus 5y is 21. And x plus 2y is equal to 8. Isn't it? Equation 1, equation 2. What you can do is, now we are going to find out the determinants. Delta. Delta is, first of all, what is delta? It is the matrix of determinant of determinant involving the coefficients. So what are the coefficients? 2. Here it is the coefficient of x is 1, 5 and 2. So x column coefficients and the y column coefficients I'm going to put here. And I'm going to determine the value. So when I'm going to find the determinant, it is 2 into 2 minus 5 into 1, isn't it? That will be 4 minus 5, which is 4 minus 5 is minus 1. So delta is minus 1. Next is delta x. Delta x will be the determinant consisting of the same values, but the x coefficient column is replaced by constants 21, 8, 5 and 2. Okay, so you see in this column, you can see here I marked in yellow. This represents your x coefficient column that is replaced by constants. We call it as delta x. So again, use the same thing. So the products will be 21 into 2 minus 8 into 5. 21 into 2 minus 8 into 5. That is 42 minus 8 5s are 40, which is equal to plus 2. So delta x is plus 2. I'll just try to accommodate delta y here itself. So what is delta y? Just like delta x, by the same logic, from delta you have to replace the y coefficient column elements by constants. So you have 2 and 1, replace it with 21 and 8, and of course perform the multiplication of the cross multiplication, finding the determinant. So delta y will be what? What will be delta y? Delta y will be 2 into 8, which is 16. Okay, minus 1 into 21, which is 21. 16 minus 21 will be minus 5. Okay, so now what is x? X is delta x upon delta. So what is the delta x upon delta? So delta x is what? What is delta x? So delta x is 2 upon delta is minus 1, 2 by minus 1, so x is minus 2. And what is y? Y is equal to delta y by delta y by delta, where delta y is minus 5 by minus 1, which is 5 plus 5. So we got the values of x and y. This is the Kramer's rule, the determinants method. This will be helpful for students of grade 11 and above. Kramer's rule. All right, Kramer's rule. The next method is the matrix method. So in this, what do? I have to write this in the matrix form as Ax is equal to B. So now go back to my two equations. I have 2x plus 5y is 21. 2x plus 5y is 21. And x plus 2y is equal to 8, isn't it? Okay. All I got to do is, I'll have to write matrix A, which is the matrix of all coefficients, that is 2, 1. See, coefficient of x goes without saying it's 1, isn't it? It's like, I need not tell you that, but it's understood. 1x means x. X is, of course, the matrix of the unknowns, the variables, which we need to find out, which is x and y. B is the matrix of all my constants, which is 21 and 8. Yeah. So if you go with this in matrix methodology, what do? We are pre-multiplying by A inverse, isn't it? A inverse into A into X is equal to A inverse into B, and where A is the inverse of A, assuming that it's non-singular. A inverse into A is I, matrix I into X is A inverse into B. So X is equal to I into X is, of course, I is identical to R, 1 in number system. So X is A inverse into B. And I just have to do this multiplication. So what is X? X is equal to A inverse into B. My question of A inverse. A inverse is important now. So what is my A inverse? For that, I need to find out um, adjoint of A and determinant of A. So what is adjoint of A? Yeah, I'm going to replace every element of A by the cofactors and then take the transpose. Transpose of the cofactor matrix is called as my adjoint matrix. Cofactor of 2 is 2. And please remember the sign conventions, which is very important here. Plus, minus, minus, plus. So for A12 position, cofactor of 5 is minus 1. Cofactor of 1 is minus 5. Cofactor of 2 is 2 itself because of the sign convention. Keep this here. And your adjoint of A will not change, isn't it? What will that be now? We'll just put that down here. Yeah. So it's transpose. You take the transpose, its rows become first row becomes first column. Second row becomes second column. There you go. And what's determinant of A? Determinant of A will be, what is it? 2, 5, 1, 2. You take your, you're going to take your values this way. So determinant of A is 2 to the 4 minus 5, which is a straight negative 1. Yeah. So I know what is adjoint of A. So what is adjoint of A? Adjoint of A, what is it? Let's write that down again. So adjoint of A will be 2 minus 5 minus 1, 2, row wise. 2 minus 5 minus 1, 2. What is determinant of A? Determinant of A, we just now found out it is negative 1, isn't it? And what is A inverse? A inverse is 1 upon determinant A into adjoint of A, right? So that will be 1 upon minus 1 into 2 minus 5 minus 1, 2. So obviously this 1 by minus 1 is negative, right? So there's a minus 1 outside the matrix, and I would write this as minus 1 into 2 minus 5 minus 1 and 2. We can transfer the negative inside. Okay, so it becomes minus 2 plus 5 plus 1 and minus 2. That is my A inverse, but it's still not over because we need X. X is equal to A inverse into B. Perform matrix multiplication, and we know matrix multiplication minus 2, 1, 5, minus 2 into, so if you go with your B, matrix B is 21 and 8. So now you just have to do, so 2 rows, 2 columns, 2 rows, 1 column. So it will be 2 by 1 matrix, minus 2 into 21, minus 2 into 21, plus 5 into 8, because the concept is the same. We're just using different methods. 5 into 8, I'll just write down that 8. And here it will be 1 into 21, 1 into 21 minus 2 into 8. Okay. So what will be X matrix? Minus 2 into 21 is 42. 42 plus 40. And here down it is 21 minus 16. Yeah. So that will be what? 42 minus 40. Because it is minus 42, right? So yeah, so it will be minus 2 and plus 5. That is matrix X. Yeah. So matrix X is minus 2 and 5. But what is X? When I defined what is AX equal to B, remember, A is the matrix of coefficients, B is the matrix of constants, X is representing the variables, isn't it? The unknowns. And I've precisely got them in the order required. So X is negative 2 and Y is 5. This is the matrix method. See, if you have seen, we've already seen 5 methods so far. Yes, starting from substitution, I went on to elimination, and then I went on to RCM, spoke about Kramer's rule and a determinant method, and now it's this matrix method. There's one other method. There are many methods. Another method is the Gauss-Jordan elimination method. So we have to augment the matrices here. So this is pretty much like what I do is I'm going to consider both my matrices, that is A and B, that is the matrix of coefficients and the constants together. So my equations are what? I will just write them down for reference. 2x plus 5y is equal to 18. 2x plus 5y is equal to 21. And x plus 2y is equal to 8, isn't it? Okay, there you go. And then I will write the matrices together. 2, 5. It's very much like your matrix method, but then you're going to augment the matrix with 21 and 8. Okay, and then what do? I have to augment it. I'm going to partition it. So it's like I've attached this 21 and 8 to my existing B. It's like A versus A augmented with B, I would say. That's what I'm doing here. Now, what is the next thing that I have to? I'm going to apply a series of transformations. I'm going to do row transformations, and I'm going to, this is Gauss-Jordan elimination method, because there are many other methods. But since I'm talking about Gauss-Jordan elimination method, I'm going to apply a series of transformations. And what? I'm going to reduce the matrix on the left-hand side to an identity matrix. Okay, I'm going to apply only row transformations. Please remember, we are not going to mix the matrices, mix the transformations rather. So we will, so if this is row 1, just for us to understand the convention, and this is row 2, the first thing is, see, I want to get my identity matrix. Look at the structure of the identity matrix. It's 1, 0, 0, 1. So what I can do is I can convert row 1 to row 1 minus row 2. So I get, and when it's an augmented matrix, right? So whatever transformation I apply on the LHS type side should also apply to the RHS. So it becomes 2 minus 1. See, row on top I have 2, isn't it? I have 2 here and I have 1 here. So 2 minus 1 is 1. 5 minus 2, 21 minus 8. Okay, it's simple that row 1 is now transformed to row 1 minus row 2. That gives me 2 minus 1 is 1. 5 minus 2 is 3. I'm not changing, or I'm not transforming the row 2. Row 2 is untouched. It remains as it is. 21 minus 8 is, this is going to be 13, and this is going to remain as 8. Okay, so this is what it is. Now look at the structure of the identity matrix at every step. I've got 1. The next thing that I need to get is, I need to, I need to get 0 on the, I need to somehow get 0 on my, on this position, that is on the second row. So element 1 is there. So in that position, I need to get 0. So what I can do row 2 as, row 2 is row 2 minus row 1 now. So that becomes 1, 3, 1 minus 1 is 0, 2 minus 3 is minus 1. Okay. And yeah, of course, I have noted my augmented matrix also is there in place. So let's not forget that. So it will be 13, and 8 minus 13 is a negative 5. Next, what I should do is, I need plus 1, isn't it? See, there is minus 1 there. I need plus 1. So row 2, I'm going to multiply it with negative 1. Okay. So I'm just trying, see, there's like no hard and fast rule. So if you're doing, you might start off with a different method. Ultimately, we need to get an identity matrix for the LHS part of the augmented matrix. That's what is the idea. So row 2 will be what? So 1, 3, row 1 is untouched. Keep it as 13. 0 into anything negative, it doesn't matter. -1 into -1 is +1, -5 into -1 is +5. So now I'll just take it to the next page. So I have 1, 13, 0, 1, 1, 3, sorry, this is 1, 3, 13, 0, 1, 5. 1, 3, 13, okay, 0, 1, 5. Now what do I do is, I can do row 1 is row 1 minus 3 times row 2. See now what happens. So I get 1 minus 3 times 0 is 1 minus 0 only, which is 1. 3 minus 3, which is 0. Okay. And 13 minus 3 times 5 is what? 15. 13 minus 15 is -2. So row 1 is row 1 minus 3 times of row 2 corresponding row 2 elements. Row 2 is untouched. Yes. So what did I obtain now? If you look at it, look at the original this part. If you look, I got my identity matrix in the augmented part, right? Of the LHS of the augmented part. Obviously, the first one corresponds to your X, the second one is your Y. Okay, this is the Gauss-Jordan elimination method. I'll just write that out for you. So it is called as the Gauss-Jordan because the credit goes to both the mathematicians, Gauss-Jordan. So it is more precisely, it is called as the Gauss-Jordan elimination method. It is, see, it's not your normal elimination. It is called as the Gauss-Jordan elimination method. Okay. All right. So you're eliminating here, but see what you're doing is you're using transformations, yeah, row wise and row wise transformations for matrices, and accordingly we arrived at this. So yes, so we have got this. The first one signifies your first unknown, that is X. The second one corresponds to your, so it is in that order, isn't it? This is for X, this is for Y. The columns are accordingly meant, and so accordingly in the augmented portion RHS side you get the values. So this is the, so now if you go back and compare, yeah, so in all the methods that we have discussed so far and all this substitution, general elimination, we can't do special elimination. That's only when the coefficients of both are swapped, isn't it? That's not the case here. So we'll just go with normal elimination. RCM technique, after RCM what is there? We have seen the Kramer's rule. We have seen the matrix method, general matrix method, where we find the inverse of the matrix using adjoint concept, determinant concept. And the other thing is, we have also seen this method, that is the Gauss-Jordan elimination method. In all the cases, if you see, we're going to get the same thing, isn't it? X is -2, Y is 5. So it doesn't matter, isn't it? Finally, so the method doesn't matter. Now we can compare, because some cases matrix method may be suitable, some cases our basic elimination may be suitable. So there are many things to this. So I hope that explanation has been helpful to you. I hope you enjoyed the learning, and more importantly, the comparative study of the various methods in place.